Hello everyone, I am Dr. Tanmoy Biswas. I welcome you all in my channel TanmoyChem. Today's topic of discussion is one MCQ and the question is in front of you. As usual, I request everyone please pause the video, try by yourself, and whatever answer you get please write in the comment box along with few words as explanation. I believe we have tried, so let's start. Now the question, what is the major product of this reaction? Now if you look at, this is an aromatic ring attached to 3 ethyl group. Okay, their relative position also important. First is this acetyl chloride LCl3, second another. So it's a two-step reaction. So when steps are more, it is better to look at the first step and the reagent. Then it become easier. Now first look at the reagent. So if you look at this aromatic compound, and this condition is actually a aromatic electrophilic substitution. Okay, or Friedel-Crafts acylation. So here electrophile will react with this ring. So what is the electrophile? In this case it is acylium cation. Now by the way, if you look at electrophile means actually electron deficient species. So where it will preferentially react? Obviously it will react with electron rich carbon center of the aromatic ring. Not only that, it must be attached with one hydrogen such that substitution reaction can take place. Now there are 3 types of hydrogen available here, H1, H2 and H3. Now question, where the electrophile will act? For that purpose we need to understand in which position the electron density is maximum. Now if you look at ethyl, by the way ethyl group means CH2 CH3. This ethyl group can show 2 types of effect to the benzene ring. One is plus I effect, obviously through the sigma bond, and another is actually hyperconjugation. Since all are ethyl, so these 2 hydrogens are responsible for hyperconjugation. So these 2 kinds of effect you can expect. And these 2 effects are donating, means this ethyl group is actually electron donating group. So it will increase the electron density in the benzene ring. So aromatic electrophilic substitution will take place smoothly or easily. So you can say, okay, due to the presence of these 3 ethyl group, this ring is activated for AES. Now still question, where? Hydrogen 1, 2 and 3. By the way students, since ethyl is an electron donating group, each ethyl increases electron density to its ortho and para position. It's a very important student with respect to one ethyl ortho and para position. Okay. Now if you look at with respect to ethyl 1, if I name, so this is ortho but not possible here and here, but ethyl is there. So only with respect to E1 this side is ortho. Okay. Now logic 1, let's go to the logic number 2. If you look at this ethyl, so only this position and this position, so H1 and H2. Okay, so these 2 position possible, aromatic electrophilic substitution. Now third, with respect to this E3, if I say both H2 and H1 possible. Now from the statistical point of view, this position get activated by one ethyl group. But if you look at H1, this position and this position, they are activated by 2 ethyl groups. Okay, so this much we understand. Now question, then either at this position or this position, anywhere electrophile will attack. But question, which one is more preferred between these 2? If you look at with respect to this, both side there is ethyl. Okay, this ethyl group student significant, it has a bulkness, means CH2, CH3 and CC rotation allowed, so it has a bulkness, a steric effect. But if you look at this side, I am talking about this position. If you look at this position, this side, one hydrogen, one ethyl. So this position is associated with less steric effect. So if it is associated with less steric effect, the electrophile can preferentially go. Actually, every chemical reaction happens by collision of molecules, ions or species. So in this case, collision is preferred because one side is relatively less bulky, hydrogen. Actually, hydrogen is the smallest atom. Okay, but in this case both side ethyl, so bulkness or steric effect is more at this position. Now the electrophile will not react. Now if you look at this is CH3 COCl, I am not going to mechanism student. In presence of anhydrous AlCl3, these 2 react and produce CH3CO plus AlCl4 minus. This is, and this positively charged ion, or you can say in this case its name is acylium ion, is electrophile. And by the way, this acylium ion can have another resonance. I mean, these one of the two lone pair can participate in resonance. So how it can give here, and it will be CH3C triple bond O. Now in the second canonical form, every atom, this carbon, this oxygen, both are octet filled, but here this carbon center is 6 electron species, electron deficient. So this is the reason why this resonance happens. And by the way, this is sp2 hybridized, but this is sp hybridized. Remember this. So now question, where the nucleophile, I mean this benzene ring will attack? Obviously this carbon atom, because carbon-carbon bond is more stable. So this position, I mean I'm talking about this double bond will attack there. At first step, what it will produce? Now this position, the electrophile got attached, I mean this CH3CO part. Now rest of the thing I will write as it is. By the way student, I suggest everyone, please write this. You may think, sir, I am able to do it by just calculating. No, if you practice, if you write it, you can remember it better. By the way, previously if you look at this part, this is aromatic, but in this case this is sigma complex, the aromaticity is lost. So that is aromaticity stability. So that stability is destroyed here. So how can it get back the stability? By release of these hydrogen. So these hydrogen will leave as H plus. This bond pair will come there and it will produce the aromatic species again, but aromatic electrophilic substitution will take place. Okay, so this is the product. Now you may ask one question, sir, will the reaction stop at here? Yes. Remember, this CH3CO, this molecule is actually electron withdrawing group because of the minus R effect of this carbonyl group. So it is electron withdrawing. So if you compare your starting material versus product, so product is less electron rich. So obviously it is less active for aromatic electrophilic substitution. So preferentially first all the reactant will consume for this reaction. And if you take proper calculated amount of reagent, so this will be your product. So this is often clear. Now what about the fate? So these hydrogen will come out as H plus, and previously one Cl minus goes and attached with AlCl3. So both H plus and AlCl3, so Cl minus, they combine and produce HCl. And in this way AlCl3 will be regenerated, so catalytic amount of anhydrous AlCl3 is enough. By the way, why anhydrous? If moisture is there, that can hydrolyze this aluminium chloride. By the way, a aluminium chlorine bond, this is actually a covalent bond. But yes, you may consider, sir, ionic, no, it's covalent. Only aluminium fluoride is ionic. So this is a polar covalent bond, if I say. So in presence of water, water is also a polar molecule, so hydrolysis is possible. So this chlorine will take the hydrogen and 3OH will replace 3Cl, aluminium hydroxide. Aluminium hydroxide is not that much electron deficient like aluminium chloride, so reactivity will be reduced. That is the problem. That's why anhydrous AlCl3 is taken. Now let's go to the next step. Next step, here it is taken hydrazine. So hydrazine is actually here the reducing agent. Now you may ask, sir, okay, hydrazine is acting as a reducing agent, so it will reduce this carbonyl to what? Obviously methylene. By the way, this is also ethyl, means CH2, this part will be reduced to CH2. So CH2, CH3, and rest 3 ethyl group will be written as it is. Agree? And the double bond aromatic part will show as it is. This is. Now, this is the reducing agent. So what is the fate of this hydrazine? It will be oxidized to nitrogen compound. This sodium hydroxide is basic. Provide the basic medium. In basic medium, the reduction takes place. And this is tetraethylene glycol. So it is actually, student, a high boiling solvent. So if you look at, this is your ethylene glycol. If I say this side OH, this side OH. If I put one, so it is diethylene glycol. So again triethylene glycol. Again tetraethylene glycol. Okay, so in this way you can say ethylene glycol, diethylene glycol, triethylene glycol, tetraethylene glycol. So this is a very high boiling solvent. Okay, so that's how you can heat it in high temperature such that reaction can be done very smoothly. And this is actually reduction of ketone to hydrocarbon under alkaline medium. So this is the overall product, this 4-ethyl group. Now, what are the name reaction? By the way, overall reaction is Friedel-Crafts reaction, but it is a branch, Friedel-Crafts acylation. Why? Because in this reaction, this acyl group got attached to this benzene ring. That's why acylation. And the second part is actually Wolff-Kirschner reduction. By the way, I've already discussed, dedicated few videos on this WK reduction. You may visit for further learning if you want to. So this is the product. Now, what is the major product? Obviously, option B is the major product. But now, if this question appear in your exam less than 30 seconds, how can you solve? By the way, student, you need to calculate very quickly with respect to, so 3 position, 1, 2 and 3. Just I have shown this position is activated by 1-ethylene, 1-ethyl, this position and this position activated by both. So okay, now this position is sterically demanding because both side ethyl. This is less sterically crowded. So here the reaction will take place. So first acylation, Friedel-Crafts acylation reaction, and this is WK reduction. Sometime in place of sodium hydroxide you can get KOH. In case of tetraethylene glycol you can get ethylene glycol, diethylene glycol, triethylene glycol, anything. So this is, so in this case, okay, so 1-2 relation, in between a break, both press, again 1-2. So 1-2 in between a break, 1-2, so only 1. Okay, if you do this, it's very good. Otherwise, if you do not understand these also, you can calculate in a back calculation strategy. Means this position, if happen, it's associated with bulkness. So 1, 2, 3, 4 not possible. Next option, if I say again here 1, 2, 3 rather than less bulky side available, so it's a question. Okay, and if you look at this is a completely wrong option, student, because here it's a methyl group, reduction in carbon, no, that not possible. Okay, so this is a completely dummy option. You should eliminate this option at the beginning. Now what is this gone confused, but this is perfectly right. If it attacks associated with less bulkness, this is the product. Okay, so I request student, please read this, try to understand the concept and practice more and more questions, then it will be easier for you. So this is the overall discussion. Thanks for watching. See you in my next video. Bye bye.